to the Weekly Bioanalysis, a KCAS podcast.
Hello and welcome to the 80th episode as part of our third season of the Weekly Bioanalysis, the official podcast of KCAS Bio. KCAS Bio is a bioanalytical lab serving the pharmaceutical and biopharmaceutical industries for over 40 years. My name is John Perkins and I've been in the bioanalytical LC-MS space for around 30 years. I'm here with my co-host Dominic Guarino.
Hello, my name is Dominic Guarino, and I've been in the bioanalytical ligand binding assay and biomarker space for a little over 31 years now. Gotcha by one, John.
Yeah, there you go, whatever. Dominic and I are members of the growing scientific advisory team at KCAS. Either or both of us are available to answer any questions you may have regarding this podcast or any of KCAS Bio's services. Today we're here with a guest, Carrie Vyhlidal, Associate Director of Cell and Gene Therapy at KCAS Bio. We are thrilled to have you listening to the 80th episode of the podcast, which is now available virtually everywhere. Wherever you choose to find and play your podcast, you can now likely find the Weekly Bioanalysis. We welcome all of you, whether you are joining us for the first time or if you're a regular listener. Today's podcast will be a review of the latest news and resources, and then a focus on the topic of our choosing before discussing any feedback we've had from you. We're consistently looking for topics, and we'd be happy to discuss something that you want us to cover. So again, we're excited to have you here, and we're looking forward to a fun episode today. To kick us off for podcast number 80, Dominic is going to go over today's podcast topic a bit before we jump into the news and resources section. Dom.
Yeah, John, we got a great episode ahead with our guest. As always, we're going to start with our news and resources. The main portion of our podcast today will be call it the rapid evolution of PCR assays. And Carrie is going to help us go over the current landscape. And when I say the current landscape, I mean the current regulatory landscape for PCR-based assays. We're going to focus a little bit on the recent publication that she's on, as well as some of the challenges in data analysis, maybe impact of AI on some of that data analysis, as well as just closing out with, some of the latest and greatest in the industry and what we think where the industry might be going. So with that, John, let's just dive right into the news and notes. Interesting first article here and really hot topic, the CNS space, the neurodegenerative space, Alzheimer's space. Tell us about this. Well, this cheerleader therapy, John. Yeah, what's going on there?
This is a article that highlights the issues with the CNS space. I mean, it's a high reward, high risk category research with a number of companies you work with over the years who are in CNS and then fizzle out and die because obviously things go nowhere. And because I think to a large extent it's still trying to gain an understanding of the brain, which is obviously a very complex organ. And this is one, it's all related to Alzheimer's research. It's ion chelator therapy unexpectedly worsened Alzheimer's disease in clinical study. This was done at the University of Melbourne in Australia, led by a guy called Scott Aitken at the Florey Institute there. And he said basically the background to this is iron has a role in Alzheimer's disease, but it's not clear. So iron is vital for transporting oxygen in the blood and producing energy from mitochondria. But there's an opinion that too much iron in the brain can be a bad thing. Because excess iron can cause cell death through ferroptosis that's believed to contribute to Alzheimer's. And in one study, people with increased iron in their brains at death had a faster rate of cognitive decline. In another study, higher levels of the iron storing protein ferritin in spinal fluid were linked to worse scores on cognitive tests. So this trial had 81 people with mild cognitive impairment or early Alzheimer's, and they were given a drug called deferriprone, which is an iron chelator, so it's there to mop up the iron from the system, basically remove any extraneous iron. And that was the theory behind it, was that it would actually help patients. But what they found was the exact reverse, was that people who got placebo, their cognitive decline it was declined by 0.295 points, whereas those who actually got, and I don't know how the point scale works, but while those who got the actual drug declined by 0.863 points. So basically, the patients on the drug got significantly worse, suggesting that the iron depletion that's not a route you should be pursuing. So although iron is implicated in Alzheimer's, ultimately this study shut down one path of research, and we're going to have to come at iron a different way, still trying to gain an understanding of how it affects things in Alzheimer's.
Yeah, John, I think sometimes these. So it's funny, right? Most of the time we report on stuff that's
Exactly.
this worked. I love that you kind of selected this one that said, hey, this didn't work, and that's a lot. Like that's like 85% of the time, right? It's a
Yeah.
lot of it's a lot more of that. I mean, that's an arbitrary number I'm making up, but like you know what I'm saying, John. Research wise, I mean, it is a lot. You spend a lot of time doing these things, and your hypothesis looks good here. Hey, there's excess iron, and by the way, right, like excess anything in the brain can be bad, right? So that is but I think I love that they made this investment, or research showed it didn't work, but like yeah, this is still it's really it's probably how do I say this? So Alzheimer's research is a good 20 plus years now, right, John?
Oh God,
And
yeah.
there's been a myriad of biomarkers that were putatively going to be diagnostic factors that, this is the cause and this and that. And you can go through taus and A betas and
And is it plaque that's
NFLs and T. There's a
responsible?
whole, sorry, what was that?
I said, is it plaque that's responsible? Is it
Yeah.
tau? I mean, there's all these
Yeah,
different
there's a
camps trying to
yeah.
figure it out.
And then what they found out is like anything else. It's like a dual-edged sword, meaning you need these things. It's just the level that is normal for my, say, CNS versus, sorry, CSF versus yours, or however you want to think of the central nervous system, right? That is the biggest challenge, because as we start to measure these biomarkers in cerebral spinal fluids, we're seeing these like the normal range is huge. So you have to be really lacking it, or this is a PhD term, a boatload excess of it, right? and so you get it. So and then 90% of it's in the, or 95% of it's in the disease state still falls into what. So then they do these ratios and they're looking at all these things. But John, I've been I get some random podcasts every once in a while. I will people send me stuff, and Tom Sposito, one of our BD directors, sent me one, and I don't even remember the name of it, but it's a great one on health, and it's a bunch of MDs and PhDs talking about health. And one of the factors to really trying to prevent yourself from aging. So if you did like a battery of clinical tests to show senescence, aging, what they're finding out is your VO2 levels and your lactose levels, not lactic acid. And there's a lot of confusion around that. And there's a whole bunch of stuff that we learned about in some of our biochemistry around the pyruvate lactic acid cycles and pathways. John, I don't know how much you know about that, but there's a bunch of misnomers about how that and what we all learned. But what I'm driving at is they're finding that your VO2 levels, basically your circulating oxygen levels, and your lactose levels are what can prevent you from senescing. So like if you can maintain that, and that the podcast talks about that a little, but they're finding that's an Alzheimer's marker too. So that's, I was kind of getting into, like, I was trying to get into what's germane, what the hell's Don talking about, right? But there's those types of markers. It's John, I think I think this is something where they all might matter, but the reality of it is the brain and the mesh, the network, the soft tissue, the lack of technology, the lack of accessibility plagues us. I'll
Yeah.
stop there, John.
Yeah, and don't worry, we're talking about it later. But yeah, I mean, I think again, it's all these things are interlinked. So if you pick one, then it's not necessarily going to be the magic bullet that fixes things. But I think it is, with something like this, it's always interesting. They prove something negative, but out of so much research out of something that didn't work, positives can come further down the line. And so it's any result like this is good and useful. It's just it's really disappointing if you're the one that's getting the negative result. That
Well, I mean,
show.
it told
What
him
we thought
something, right,
was
John? Like, we
working.
can move on, but it told him something. It
Yeah,
actually had a
exactly.
negative
Yeah,
effect. So there
yeah,
is iron plays a role, but
yep, yep.
that's I love science in that respect. But you're right. I think as if there are any young scientists listen or people who are thinking about getting into the field, man, those negative results, don't ever let that get you down because
No,
that's
no,
usually
absolutely
where
not.
the magic
No,
happens. Yeah.
absolutely not. It just, yeah, so when you regroup, think about it, learn from what didn't work, and come back at it. That's how we all function. So let's move on to the next article. This is new antibiotic kills flesh-eating bacteria in preclinical study. So this is a group Michael Caperon and colleagues at Washington University in St. Louis. Um, they were looking. They basically been working on a new antibiotic that's proven effective when pitted against certain bacteria in lab conditions. But they've actually moved this to mice, and their actual interest wasn't so much in flesh-eating bacteria, which is necrotizing fasciitis. It's actually they were more interested in looking at how a bacteria called Enterococcus faecalis caused urinary tract infections in people with catheters. The catheter irritates the bladder, causes bladder cells to release a wound healing molecule called fibrinogen, which builds up on the catheter and is then a target for E. faecalis to latch onto. They had links with a guy, Frederick Almqvist at Umeå University in Sweden, who'd been looking at developing compounds for different bacteria. He's actually trying to preventing E. coli from binding to surfaces. So they borrowed a couple of Almqvist's compounds, one notably called PS757, and to see how that would work against the the Enterococcus faecalis, and what they found was not only did it prevent the buildup, it actually killed it killed the bacterium outright.
I think they're
Um,
using biofilms of some sort, it reads here.
yes,
But yeah, yeah.
yes, and from then they then went to the Streptococcus pyogenes, which is linked with these uh, ulcer causing linked to microbes causing ulcers and ultimately necrotizing fasciitis. Because what they found with this drug is it was really good for eliminating gram-positive bacteria.
Mm.
And so they then took this to mice, and they found that for mice, the drug they called PS757 really drastically reduced the amount of tissue damage in mice with ulcers,
Mm.
compared to obviously untreated mice. So they had 15 or 20 treated mice had shed the scab that grows over the ulcers and replaced it with new healthy skin, whereas only 4 of 19 untreated mice showed that level of wound recovery. So it also PS757 also could kill biofilms of this Streptococcus pyogenes. So that slows growth. It prevents them building a protective matrix around themselves. So it's basically given a good way to attack this biofilm matrix and actually hopefully solve a problem.
Yeah.
So as a net result, obviously they want to take this further. They basically they founded a company called KCAS Bio, and they're going to see how this is likely to work, and obviously see if this has potential in the long term.
Yeah, fascinating stuff here, John. Unfortunately, the article seems to give me more questions than answers. And maybe the first one is I can't tell what this PS757 is. They don't really mention what it
It's
is.
just
Right?
I think it's just a small molecule.
Yeah, but that, you say just a small
Yeah,
molecule. And
that doesn't
yeah.
obviously. Well, I mean, if they're starting a company, they're not going to tell you what
No,
it is.
I know, but
It's proprietary information.
it makes it hard to want to dig in on what kind of have a
Yep.
good
Yep.
scientific talk. But with that said, that one of the things that, and immediately when I kind of, and by the way, I kind of, this popped out at me because we love this, right, John? This is great stuff. Like we
Yep.
definitely need more people researching antibiotics. It is not a, excuse me, not a big strength of mine. I don't, this is more in your wheelhouse, a little bit more in your wheelhouse. I mean, I know about microbiology and this and that, but the drugs themselves, the compounds themselves, is not something I've researched heavily. Where I think you and others in our company have a better understanding of how small molecules work. But with that said, the interesting piece is combination drugs, and they mention that in
Sure.
here.
Yep.
And but more importantly, I believe from what I'm reading here, and um, I think the efficacy in the mouse model surprised him, right, John? That was what kind of surprised him. Is that a good way to sum this up? Just how effective it was,
I think so. Yeah. Yeah.
and the use of it, right? Is you mentioned catheters and all these things. I mean, these things plague us in hospitals, John. Right? Like
Yep.
a lot of people get cured of whatever they're going in for, but they succumb to other things. And again, I'm not knocking hospitals. That's just what happens when you cut somebody open and they're old, right? Or you have an aged patient. So with John, it's a fascinating thing. We love the items that are maybe not immuno-oncology, right? And these scientists are working real hard. There's some Emory scientists in here, I think, and as you mentioned, Sweden and the Cure Tech, but great stuff. And certainly going to make me sleep a little better at night knowing we got. And I think there was. Hang on, wasn't there? There was another article too. I don't. Maybe it just came out, but I did see somebody did come out with a something that was going to kill MERS. So maybe we'll cover that next time. I don't know if you saw that, but there was a super. They called it a super antibiotic. So I don't know if this is in the same realm, but awesome stuff.
No, this is different, and maybe that's a different. I'm not sure we didn't talk about that, or we may have. Yep.
No, I think it just came out a couple days ago, John. I saw
all this stuff is fascinating in terms of. I mean, again, we talk about antibiotics. We talk about antibiotic resistance. We talk about, it's a difficult field to make money on, but it's still absolutely essential.
But every one of us, John, every single one of us, as we get older, should be wishing we had better meds for antibiotics.
It's absolutely essential that we have these medications coming through. And I talked. Obviously, we talked last time. I'd just come over COVID. Well, it's taken me a long time to get over that. I got really run down, so now I'm dealing with diverticulitis. So
nice.
I'm on antibiotics for that. So yeah, I'm always interested. What antibiotics
you're making my sprained ankle seem like nothing
to help deal with the next thing, So anyway, let's move on, because this is when you talk about penetrating the brain, this is fascinating. This was the one I actually pulled together an agenda last time, and this was the one. This actually appeared on the day I'd already written the agenda. It's like, no, I'm done. I'm going forward. But this is fantastic, and this is a brain parasite has been turned into a drug delivery system. Basically, we all know about any cat owner knows about toxoplasmosis, and the what's behind it is Toxoplasma gondii. It's a protozoan parasite, and I'm lifting directly from Fierce Biotech here. It says it's famous for its cunning ways. This microbial manipulator can only reproduce inside the cats. So if it finds itself inside another mammalian host like a rat, it alters the rodent's behavior to make it less fearful of felines. This effect has even been found in wild spotted hyena cubs who behave more boldly towards lions when infected with Toxoplasma gondii. So basically, there's a neuroscientist called Shahar Bracha at the Massachusetts Institute of Technology genetically modified Toxoplasma gondii to work about delivering drugs across the blood-brain barrier, because obviously what is happening in these rats, if they get this protozoan in it, it's getting across the barrier, altering behavior, making them, like I say, much more friendly towards cats, and then furthering.
John, I got to stop you. That is so funny, right? I mean, think about what you just said, right?
I know,
literally this little bug, this parasite, causes other animals to get eaten by the cat. I mean, the evolutionary...
So it can be reproduced.
This is unbelievable. The Darwin evolution theories behind how that has happened. Because think about... Sorry, I got to jump in. But the viruses do this, right? To evade the immune system. They have decoy proteins, all sorts of stuff. I cannot believe you can get a whole organism to do it. Who knew? Sorry, John. That's unreal.
No, it's fine. It's brilliant, this. So basically, so Dr. Braca's a theory was looking at this as a new avenue for safely and effectively getting drugs to the brain to treat neurological diseases. And this goes back to what we were saying in the Alzheimer's thing of that difficulty of penetrating the brain. And this is early work, obviously, but it's looking at this new avenue. This might be a good way to really help that approach. So yeah, so basically it's all about delivery, and so I'm just going to lift a couple of things and I'll throw it back to you. To successfully infect host cells, Toxoplasma gondii uses 3 different protein secretion systems. 2 of these hinge on structures called rhoptries and dense granules and are used to make proteins destined to infiltrate cells such as neurons. These were BRCA edited the genes controlling proteins by these systems so that Toxoplasma gondii would make what's called a fusion protein, which is essentially a parasitic protein stitched together with a therapeutic protein, and this way turned the parasite into a living, moving miniature drug factory. And so the focus was on a single protein called methyl CpG binding protein 2, which is associated with the Rett syndrome. So it worked first of all in mammalian cells, but basically what happened, they saw that the MECP2 was actually being delivered to the cells, and then she worked and showed that it could Toxoplasma gondii could deliver that same protein inside of cultured fibroblast cells, neurons, and brain organoids. Before giving the engineered parasite its biggest test, she injected the protozoans into the abdomens of mice and then euthanized the rodents 18 days later. Cutting out their brains, she saw that Toxoplasma gondii had successfully made it into their neurons and delivered MECP2.
I mean, unreal, John.
It's fantastic.
This is like straight out of Star Trek with Khan and putting the worm in my ear. I mean, that's what it feels like. This is unbelievable, right? So this is the next, like when you think of I can't quite tell when people started using like lentiviruses and AAVs. I think it's maybe 20 or 30 years ago. I guess our guest might know, Carrie might know, but it's certainly several years ago. And I'm sure that this feels like whenever somebody started doing that, someone looked at him and probably said, "Why would you want to use associated virus? That's dangerous." And here we are, right? I mean, it's fascinating.
They actually touch on that in the article. They basically say, so they've BRCA has set up a
biotech,
a company called EPS Pharma, and basically their focus is turning this into a vehicle for drug delivery. And one of the first things they have to address is ensure that the downside of Toxoplasma gondii has been addressed, and that there are no side effects from that.
Well, I mean, we don't think there are. It only grows in cats. The only problem is maybe the cat tries to eat you. But oh my God, this is great. This is a great story, John. I mean, the whole thing is fascinating all around, right? Like to start with this novel parasite, right? And first to realize that this parasite can like usurp the animal host and make it attractive to the cat to eat them. Yeah. Crazy, right? You know, that in and of itself is just a fascinating. Boy, you could study that for decades, right? And then, oh, hey, let's take this and see if we can't figure out how to deliver drugs to something that's been eluding scientists for 25 or 30 years now. Look at that. Great. I mean, unbelievable.
Like I say, you stumble across some of these things, and as soon as you see it, you think, we have to talk about this because this is amazing.
It is fascinating, John, and it good job putting this all together. They tie in nicely, but the thought of having a new drug delivery system using a parasite that is only detrimental to cats is should be safe, right? I mean, I'm almost speechless, John. That doesn't happen often.
Well, there we go. We've achieved something this podcast. Let's move on. And this can be relatively quick, but I just like to touch on these because we actually had a session, a main topic devoted to GLP-1 analogs. These are not going to go away anytime soon because obviously they have their um their so they have the application both in diabetes and in weight loss. There's also been discussion of potential application to sleep apnea. There's other cardiovascular effects, and the most recent articles, it's I think the semaglutide being the Novo Nordisk drug had been indicated there's cardiovascular effects and helping with heart conditions, and more recently, Eli Lilly's tirzepatide, which is marked as Zepbound, actually showed that it reduced risk of heart failure outcomes in a phase 3 study. So this was in this study, it reduced the risk of heart failure outcomes like a heart failure, urgent visit or hospitalization, oral diuretic intensification, or cardiovascular death by 38% compared to placebo. So like I say, it's amazing how these drugs seem to keep popping up, and like additional applications be found for them. I think there's not much to say on that because it is showing that basically, so this is tirzepatide. It's showing it's also there's the potential application for it in MASH as well as sleep apnea. Well, Novo Nordisk's Wegovy has also shown reduced promise in reducing the risk of kidney disease progression. The reason why I really want to talk about this is actually the second article. This is going back to an older GLP-1 analog called liraglutide. This is another Novo Nordisk drug, and this actually was administered in a small phase 2 study of patients with mild Alzheimer's disease. So we've come full circle in the course of these news items, and it actually in the course of this small study slashed cognitive decline by 18%. So this is really interesting. The trial failed to meet its primary endpoint, which is changing the metabolic rate of glucose in certain parts of the brain. And I assume they're looking then at glucose as a biomarker for whatever with the brain. I'm not sure what the background is there, but met secondary endpoints of slower loss of brain volume and slower cognitive decline. So is this done in the UK? 204 patients from 24 clinics across the UK. They had daily liraglutide injection for a year, and then brain volume was measured with different ways. And then there were 18 tests used to test cognition. And the MRIs revealed that liraglutide reduced the loss of volume of certain brain regions by nearly 50%, and these regions included the frontal, temporal, and parietal lobes, as well as total grey matter. This reduction in brain loss went along with an 18% slower rate of cognitive decline, as measured by a composite score of the 18 tests, which was significantly different from those who received placebo. I'll pass it back to you.
Yeah, John, I just think it means all of us are going to be taking some form of
Well, they make that
Viagra and a GLP-1. We're going to seriously, because that prevents strokes. There's a huge article saying all of those Lipitors and Viagras and things like that for men between the ages of like 50 and 80. They showed a massive study that can prevent strokes. It's like immediately, John, I'm not joking you. We should be taking it. This just screams we all should be on GLP-1. Although there is, and John, you touched on it, Alzheimer's patients. I mean, this is, I don't know if wonder drug's the right word because we thought monoclonal antibodies were going to be a wonder drug. And they have. I think monoclonal antibodies have really helped improve people's lives. And clearly the GLP-1 rage is all in the weight loss. The side effects are still a little TBD, but obviously I think they probably outweigh any of the benefits. But it just seems like they keep finding things that this drug is helping people with. So fascinating stuff, John. It is. It's just every time you open a news article, it's something new about GLP-1s, and they're not always. So some of it is falling. I don't want to say short. They're just redesigning it, right, John? They're kind of tweaking it, right? Oh, hey, wait a minute. This looks promising, but if we dose this way, or we give them, and it's hard to keep track of how many GLP-1s there are, right? You touched on it. Lagrange is an older one. There's Wegovy. There's so many out there, and they all have 4 or 5 different names. They're probably all like, I don't know, pretty conserved. I think they're all very similar. But like anything else, how you manufacture it and
Well,
things like that.
these ones we're discussing are the one basically it's a peptide chain
Yeah,
within a lipid addition, which is there to help the really the PK. It
yeah,
helps
the
it
half.
hang around and help improve the half life
Yeah,
in the body. So these are all similar types of drug designs.
yeah,
There are obviously other GLP-1 coming through because these are all injected, so you've got the orals coming through. There's so much focus in this area, and every week there's another company who you weren't really associating with this obesity area particularly are have announced they've got something in the pipeline, and they've got results that look encouraging.
yeah. And
I,
I
I
think
think
people are really repurposing manufacturing. That's making all the news. People are shutting. Hey, stop producing. Make Ozempic, right?
Yeah,
So no, it is
it
great,
was
John.
interesting. You talked about the preventative, and I was looking for this, but there was a trial lead, Paul Edison, who's a professor at Imperial College London, said the slow loss of brain volume suggests liraglutide protects the brain much like the statins protect the heart, and it goes back to that comment you said earlier about taking these things preventatively. I mean, if so many of us are on statins, yeah, I think it's going to be interesting to watch to see if this truly has legs, what this means for us in GLP-1s in the future as we all get older.
Yeah, it is. It's hard to see how converting it from a biologic to an injectable to an oral doesn't have some impact. But scientists are great at this stuff, John.
Well, I mean, there's so
Yeah.
much focus on drug delivery. Who knows
Yeah.
how it will be overcome? It's
Mm.
never say never on any of this stuff. You look at everything that we are talking about today. And if we'd been talking about this 20 years ago, people go, nah, it's garbage.
Yeah,
That's never going
yeah,
to happen. And
yeah,
this is all routine for us now. I
yeah.
mean, so things are moving so quickly in this area. Um, you know, I wouldn't rule anything out.
No, it is. It's great, and the analogy to the statins is an interesting one around the heart. Great stuff, John. So I feel like we're kind of winding down our news and notes. Is that
Yep,
right?
we're done. Yep, we can move on to the main topic.
All right.
And so it's again with it's a lot of it's a real pleasure to introduce Carrie Vyhlidal to talk further with us about we got our main topic here is the rapid evolution of PCR assays. This is a topic that you're not going to hear much of me on this one because this is totally outside my sphere of knowledge. So I will listen and learn for most of the time and butt in where possible. So I think Dominic, I'm going to pass it over to you to
Yeah. Thanks, John.
lead
I think
this, and then let's get Carrie talking on how things are going in PCR.
yeah, no, thanks, John. And we don't believe that you're going to sit there silently. You're as dumb as I am. So, no, as John mentioned, we're going to kind of take this rapid evolution of PCR assays, and that's going to include things like digital drop PCR. We're just going to lump them all together. But before we dive into things, let's let Carrie maybe introduce herself. So, Carrie, give us title, a little bit of background on who and what you're about, and then we'll start. You can maybe we'll after you introduce yourself, we're going to go right into like the PCR landscape. So, hi, Carrie, and say hello and tell us about yourself.
Hi, John and Dominic. Thanks for having me today. Um, so I'm Carrie Vyhlidal, the Associate Director of Cell and Gene Therapy here at KCAS Bio. What I do here is I lead a great team of scientists in our molecular services. So anything qPCR, ddPCR, you'll talk to me and my team. Um, I've been doing PCR probably longer than I wish to admit. Um, I do remember some of the original Mikey guidelines coming out that initially guided how we should design and do PCR.
So, Carrie,
So
yeah,
yeah,
tell us about that. You stumped John and I. You got
so
it. We're
here
like, what did she say? Right?
here I am, the totally ignorant person in the corner of the room. Can you tell me in as basic a language as possible what PCR is and what it involves and what kind of measurements you're making? What are you assessing in your kind of analyses?
So, in the most simple terms, PCR or polymerase chain reaction is like a copy machine for DNA. So, I can take one copy, two copies of DNA, and I can copy it over and over till I have millions of copies at the end of my reaction. So, we've taken advantage of this, and we can add certain tags into our reaction so we can measure those copies being made throughout the reaction. And so that's where we get our quantitative or real-time PCR, is we're actually watching those copies being made, even though, you can't really see them, right?
Yeah, and Carrie, let me help a little bit. So, John, that's a good question you had there. But how that all works is, right, Carrie, and make sure I'm saying the right thing. Each time you got primers in there that can, as low as a minimal copies that it needs to bind to. But your quantitation is going to be based off of the number of cycles and replicates per cycle, right,
Sure.
Carrie? That's how it's all kind of balanced out, right? Do I have that right? And then there's like salts and all sorts of things that impact that, right? pH. Just give us a
Yeah.
little down. Maybe that's okay. I think we got. I think you answered it. Thank you. Couple things because it's fascinating to me. You said you've been doing this a long time. You're what are these Mitra? Did you call them guidelines? And I think that help us understand just because I know a little bit here, just how like for the first say couple decades of your career, how few got you. You talk about these Mitra, but for bioanalysis, there was nothing, right? And over the last 2 years is when it's become a focus. So just walk us through a little bit, because you right. Did you call them Mitra? Am I getting that right?
They're called Mikey
Oh, Mikey,
guidelines.
my bad,
So
Mikey.
nope,
I'm
nope.
mixing up micro sampling, I think. But
Yeah.
so the Mikeys, right? But that the bioanalytical world, this hasn't been prevalent until like we started doing. And John, you asked about it. PCR is good for biodistribution studies, right, Carrie? That's a
Mhm.
big part of what your business is. There's biomarker things, but the focus became when we started using siRNAs and all sorts of RNA type things, or anything that was going to deliver a gene therapy on target, and you had the potential for off target safety issues. And I think to me, that's what's jettisoned PCR into the forefront of GLP bioanalysis. So that's only really hit the forefront. I mean, people were kind of doing it. A lot of people could measure it by like some form of a LCMS methodology. But now that these things are getting much more directed and potent, and they're producing proteins and all sorts of effects, the PCR, and I'll take it back. The PCR analysis was done a long time ago as well. But I think it's become now, and Carrie will talk about this. Is it a PK assay, right? We don't like that word, Carrie. All that becomes problematic. But I have a tough time staying on mute because I got a lot of passion for this. So, Carrie, I asked you about 4 questions in one there.
So I guess probably the biggest thing is that PCR is really easy to do when it in the lab, but it's really easy to do it poorly, right? And that's where, going back to the Mikey guidelines is, it was recognized early on that a lot of people were using PCR to measure things and getting different answers, right? And kind of came down to, well, why and how. And so that's where the Mikey guidelines stemmed from. But that really didn't address a lot of the regulatory issues that we face in bioanalysis for, say, a biodistribution assay or even a shedding assay for cell and gene therapies. And so while the Mikey guidelines have kind of laid the groundwork for us, we're continuing to um, develop our best practices for how we should be using qPCR or ddPCR assays in drug development for cell and gene therapies.
So, Carrie, can I ask again a very ignorant question? So, I'm an LCMS person, and I would view that as a pretty mature technology. It's obviously it's been evolving since the this well, mass spec's been out there for a long time. LCMS, certainly I've been doing it since the 80s, and it moved very quickly. So in terms of the actual platforms and instruments, we've had them since 70s, 80s, and maybe earlier. What's the time frame of PCR, and when did it originate? Where did it originate from? I mean, what's the timeline in terms of it developing as a technology?
So actually, PCR was first invented in 1983 by Carrie Mullis. He subsequently won the Nobel Prize for this work. And really, you could probably even take it back to the 70s of when he was doing his work, developing this method. And there's some really interesting stories about how Carrie Mullis came up with the concept to do
Yeah, I was going
PCR.
to say,
But we won't. That's
well,
a whole other
I want you
podcast.
because there was no thermal cycler in 1983, right, Carrie? So he was sitting there with different water baths at different temperatures, and he was just racing around the lab, right? Isn't that what he was doing?
Absolutely. So for PCR to work, um, you have to heat it up and cool it down repeatedly, the
Okay,
reaction.
sure.
Um, and originally with PCR, like Dominic said, we'd go to a water bath and move the reaction from temperature to temperature.
Oh,
Um,
Carrie, you just revealed what year you started working in a laboratory.
This is
Let's
this
move
is all
on. No,
interesting.
no, but the thermal cycler does it all now, right? And I
yeah,
feel like we got a little bit more to cover. And so, but like John, like maybe we bring you back and we just go over blocking and tackling a PCR. But for today, I really want to but John, I hope that made sense, right? Like the
Yeah,
thermal
yeah.
cycle cycles up and down, and you
I
get an
think
annealing and all these. And part of the science, as Carrie said, it is somewhat easy. You just right, it's osmolarity, the pH, and the primer, right, Carrie? And then
yeah.
sometimes you tweak it, and so,
so,
but
sometimes it's really useful though to know the background to then
no, I
hear
think you're
about
asking
the
great
development.
questions, John. Carrie and I just take it for granted, or at least
Sure,
you're asking some things that are educating me as well. But no, it's good. It's good.
and I do the same thing with LCMS. I mean, obviously, like last week, I was doing a training course, and I've got bunch of pieces put together, and I touched on LCMS interfaces, but actually just for the sake of a little bit of introduction, went back to some of the early interfaces that were, they solved the problem but were impractical, but you still need those baby steps before you get to the piece that then makes it practical for everyone to use in the long term. However, I will go on mute again. And let you
That's okay. All right, Carrie, you're going to tell us about the mica papers here, because right? Is it mica? Am I saying that right?
Nikes.
Mikey, MIQE.
Okay.
Um, and so really they were just trying to define what sort of information do you need to provide for somebody to replicate a PCR experience. So primer sequences, the enzyme that you used for the reaction, basically the DNA polymerase. How were the samples handled? How were they collected? How was the DNA or the RNA processed? Um, what were the cycling conditions? All of these very specific parameters so that anybody could replicate any PCR experiment. But again, that really doesn't address how we assess.
Yeah, Carrie, is that for like forensics labs rather than Like, what is that paper for?
That really came out of guidance for research labs.
Okay, so it is for like biomarker testing and things like that, or even help me understand. Was it used for forensic labs? Now I'm starting to wonder more about just exactly how. So but let's move on. You've got this document. People are adhering to it. There's probably proficiency testing around the world, but like, what what is it that makes? I'm just going to say why did APS form a PCR group 3 years ago? Now you've been on it for two of them, right?
Right.
Why? What was the right? And then we can just dive into kind of what you all been working on in that group.
So again, with PCR and cell and gene therapies, PCR is a really powerful tool for tracking the biodistribution of a cell or gene therapy. So people have been using it, but there was really, and there still remains no guidance from the regulatory authorities on what constitutes a reliable PCR-based assay.
Yeah, hold the phone there. Say that again. Say it one more time so the audience and anybody who really cares about this can understand just how wild, wild west it is. I'm going to represent Kansas City.
So from a drug development perspective, there are no regulatory authority guidances for PCR-based assays.
Shocking. Yeah, shocking. So you guys have produced. Why don't you throw down a little bit about what are the challenges that have been solved? There's some there, and let's start there.
So a number of industry organizations and independent groups have published papers, white papers, position statements on what constitutes developing a good bioanalytical PCR assay. So this includes people like the European Bioanalysis Forum, the Japanese Bioanalysis Forum, WRIRB. But if you look at all their recommendations, there's a lot of inconsistencies. So the AAPS PCR working group, as Dominic mentioned, we've been meeting for about 3 years now. But just earlier this year, as a culmination of all of that work, published their recommendations for method development and validation of PCR-based assays. And in this process, we've looked at all of these other recommendations, compared them, contrasted them, discussed pros and cons, and then, all of these discussions have culminated then in this most recent publication, trying to harmonize those recommendations between the different publications, as well as ours, to hopefully present a more cohesive approach to developing and validating PCR-based assays.
Awesome. And so some of the, kind of really big rocks have been addressed. Do you want to touch on those a little bit? Like performance characteristics. Let's translate what it all means, right? When you say there's no guideline, and guidelines, by the way, are what they are. They just say, if you go get an immunogenicity guideline or the bioanalytical validation guideline, the most recent one, they list performance characteristics and they give you a little bit of flavor around what it's supposed to mean. And then there's a lot of gray. Let's call it what it is. There's a lot of gray after that. And then we spend a lot of time in things like the workshop and regulatory issues in bioanalysis, as well as the global CRO council that's associated with it. And then these AAPS focus groups, which we're both heavily involved in,
Mm-hmm.
as well as others, Brian and Don. And this is such a great, and AAPS has really grown a lot in the last few years to kind of make it a way to kind of fill the gap. So now you have this ability to fill the gap. Performance characteristics are, in my world, they're still not clearly defined for PK, but maybe you can correct me if I'm wrong. Do you feel like it has, like if someone says, what are the performance characteristics for a small molecule validation? John's going to take himself off of mute and we're going to wind him up like one of those little monkeys that slaps its hand together with the cymbals, okay? So but when I ask you that, you're kind of like, well, what do you mean? And you're going to ask me 50 questions where John's like, if I say, John, small molecule intact, right? He knows what that means. If you say to me, biologic, monoclonal, I can give you PK88, boom, boom, boom. But you don't have that luxury, do you, Carrie?
No, we sure don't. And what we always fall back on is, what is the context of use? How is this information going to be employed in support of the development of a new therapy? So it's still a bit of the wild, wild west, right?
So like, do you say accuracy, like when you write a validation plan, is it accuracy in precision of 3, or is it precision of 3, or is it like, again, you're going to say to me, I know a little, right? I know a little be dangerous, but you're like, Dom, if it's a ddPCR, I don't see any of that, right? Right? If it's a PCR, right? So just walk us through like maybe like some blocking and tackling of what that white paper went over. Did you guys come to some understanding of what are the extraction, see, these are the things, like what's the extraction process, and how do you manage that? Even what's a long-term stability sample for that look like? Do you even have to do it, right? The consensus is maybe you don't have to do all that. Then you actually have the PCR reaction itself, right? So you got like two kind of pieces that you kind of slam together. And it reminds me of the hybrid world a little bit, but the hybrid world, at least here at KCAS Bio, we've helped drive that. And I think the PCR world, and I've been on some of your meetings, Carrie, and man, it is the equivalent of nerds fighting like cats and dogs on that meeting. If you remember what we were talking about, you were on that with me, and we got off it. We were like, holy smokes. And that was was that 18 months ago now? I don't know what exactly it was. But I'm sure there's been a lot of improvement. And to the audience, what we're referring to is if you're a diagnostic lab, a CLIA lab, a reference lab, a CAP lab, all the same bucket, versus a research lab, a GLP lab, even let's say a GMP laboratory in some respects, these you two that's heresy, right? You're the CAP lab's doing all these things over here. You're like, there's no way. I'm going to violate every SOP in my GLP environment if I do what you guys are doing over there with, what were they doing? Okay, no standards, no QCs. I'm going to test the thing every month or something, singlets, whatever things that made you and I were aware of this, but others on the phone were like, ah, right? Carrie, it was a maddening thing. So where is the consensus there? And just maybe highlight it a little bit.
So, you're talking about accuracy and precision, Dominic. Yeah, we do. We discuss terms in accuracy and precision. Um, but depending on your platform, whether you're qPCR, DD, or dPCR, that may look a little bit different,
Yeah, and even if it's
right?
RT, right now you got so many different buckets, right? If it's
Yeah.
a PCR reaction, a PCR reaction, am I starting with what matrix, what tissue? So that's why it's been elusive, right? Maybe we're answering our own questions, right? The reason why, let's forget what me pressing you on what a validation plan looks like. The reason why there is no good guideline, that's a logical question, is what we're talking about right now. And you're like, Dom, it's hard for me to rattle off. And you could say, well, sure, we could do upper limits of detection, lower limits, but that doesn't mean anything in your world without certain caveats around it, right? Where John says I say upper and lower limits. I can, it's picograms, nanograms. You still have, how do you handle that? Is it a quantitative measurement? Is it a copy number, right? Those are all why the guideline doesn't exist, right? That is part of the reason why it's so elusive, correct?
Well, exactly. And so and again, it's going to depend on your platform, qPCR versus dPCR. qPCR, if you want to do a copy number assessment, you're going to need a standard curve. But with dPCR, if you're measuring a DNA, you actually don't need a standard curve, which is sort of, for other bioanalytical procedures, that's sort of heresy, right?
That's exactly the word I was going to use.
But that's just because of the nature of the assay and the Poisson statistics underlying the absolute quantification and how we determine copy numbers of our target. You don't need a standard curve. But if you're doing RT-ddPCR, where you've got a reverse transcription step to convert your RNA back to DNA, then you are going to need a standard curve, just because that's an additional step, an additional enzymatic reaction that you have to do before you get to the data for your sample.
Yeah. Great, Carrie. Good stuff there. And speaking about data from your sample, let's move over to that because I feel like that is probably so. Some of the things around that paper, and it's called the Recommendations for Method Development and Validation of qPCR and dPCR Assays in Support of Cell and Gene Therapy Drug Development, is a February 2024 AAPS publication, and that is now what a lot of people are referring to, and you're probably already in the works of making something new. But the real issues I think that are starting to pop up for a GLP environment, right, is how do you manage all this data? And so when I say all this data, each cycle has a data point to it, right, Carrie? If you want to break it down, right? So what? Talk to us about the challenges in data analysis management. And then I know you had another poster that sort of helps solve some of that. So what are some of those challenges?
Dominic, if I could just quickly jump in here, you need to move closer to your mic because you've like faded away a bit.
Oh, I'm so sorry,
Oh,
everybody.
there you go. That's
Yeah.
better. Okay.
I hope you were able to hear all that.
No, I could hear it. I'm sure Jeremy can address it. I just thought for the next piece.
It's
So
like
I'm
it's
sorry.
my first podcast, even though we're in our third season, and I think we're on number 80 today.
And then I'm sorry. I hope you still got the question, Carrie.
And just to make it easier, Carrie, I'm gonna ask the question kind of again to you, so Jeremy can edit it a little easier. So, Carrie, just please do tell us a little bit about some of the challenges in data analysis management and some of the solutions that we at KCAS Bio are working on.
Right. So as the industry's kind of trying to come together on how to develop and validate PCR-based assays, the next challenge is, like Dominic said, data management. We can produce a lot of data pretty quickly now with PCR. Um, routinely, these reactions are in the smallest size going to be in a 96 well plate. We're doing 384 well plates, and then there's even PCR arrays. So you can generate a lot of data in 45 minutes. But then performing the statistics on that and assay assessments, there's really limited tools out there for the management of that data. And so KCAS Bio has been working with Biodata Solutions to develop a red thread module that will take the data outputs directly from our PCR instruments and put them through analysis without additional QC steps at each step of the data manipulation process, and really just reducing the amount of um, data manipulation that's occurring in like an Excel spreadsheet, which is not controlled and can be very messy, um, into this cloud-based platform based on artificial intelligence to analyze the data, give you yes/no answers on run performance, and then ultimately your sample data. This tool, just from processing data, can reduce 4 hours of work down to just a few minutes of work. And the other benefit of this tool is it has a QA module that allows QA to go in and look at exactly what data was put into the system and the outputs of that data. So all the way from input to data output just gets us data to our clients faster and the answers faster.
Yeah, there's a lot to unpack there. It was good, Carrie. Yeah, thanks. The first is the red thread, and that is what machine learning AI. Talk about that a little bit, because that's what this is hot topic, right? This is all over the AAPS PK focus group. This monthly, we had a major one on AI. I cannot believe, and maybe John and I will do that as a podcast here. I think that might be a good topic for us, John, the use of AI. There are some interesting things that people are doing with AI, machine learning, however you want to call it, but that's what this is, Carrie. And what you're doing is right at the forefront of it. So red thread, we use red thread for our statistical analysis for immunogenicity cut points. It's got that aspect to it. The software can do that. Red Thread also has software that allows us to use some QA. We have some LBA group is using some QA automation, and that's pretty cool too. That like you said, it just, and then we have our eyes set on some Luminex and multiplexing panels. And you've done some beta testing here in the PCR world, right, Carrie? You got a poster on it using that Red Thread software, and you talked about, so that's the first piece, and then you kind of casually mention AI to our audience, who's probably perking up a little bit now. At least I hope they are. And then you casually mentioned, well, it can save you like 4 hours of time. What? I mean, that you should fall out of your seat when you hear that. But it's not just the time, is it, Carrie? The quality of the work is exponentially better, right? Talk to us a little bit about some of how, wherever you want to take us, Carrie. But this says, just brag a little.
Well, so a lot of this data is just handled through Excel analyses, right? And so there can be data analysis errors, transcription errors that occur. And, so then each one of those calculations, that's got to be QC reviewed and QA audited. But with this Red Thread tool, all of that is automated. And it actually checks itself. So then that's really improves our data integrity and data security. But also much faster than we could, which for me, working in the lab and having a finite team of scientists is huge, right?
Yeah, no, amen. All of it. But so what is the I think our audience, we got a little bit more time here, right, John? I want to make sure I stay on point. Have we
Take it wherever you want to go as far as
yeah, I
I'm
think we've got every topic we kind of wanted to hit on.
sure.
So Carrie, if I'm listening and you're telling me these things, maybe let us know the poster, the May 2024 ASCGT poster you had is available. But walk us through, like, how did you do it? Like, just for, maybe even use the data, the program we had. It was a biodistribution study. Walk us through, like, what's the application? Makes sense? Like, hey, we've got all this data we've been generating from 25 tissue, or 20, 12, 18, whatever it is, tissue types. We got biodistribution data on it. And instead of just pounding these things manually through Excel files, and you could say, well, they're not manual. You just have to do this and that. But there's a lot. If you have to push it through QA, it's a problem, right, Carrie? It's a lot of manual pieces to get that through a QA review. Your software bypasses that. How?
So this will take the outputs directly from the PCR instrument. So there's no data manipulation that's got to occur. We load it into the Red Thread software. It automatically regresses the data. So it'll then assess your standard curve. It'll assess all your QCs on that plate. And then it simultaneously validates all of the calculations that were performed in our code. So it's actually two things happening at once. The calculations are occurring essentially twice, and it's comparing and making sure that those calculations are consistent between the two languages.
And then but you have to educate it, right? There's a lot goes in here. It's just, right, you have to give it the boundaries of how to do that, right? Because it calculates your right. It tells you if it's passing. It back calculates things for you. I mean, it does it all, right?
It does.
Yeah, so it does all these things, and you just set up templates. You give it the scripts or whatever those sort of desired, and it flags things for you. It regresses it, right? It tells you if it's passed, fail. You still have to review it. Look, a PI still has to look at it. I'm not saying that doesn't have to happen, but there's no exporting it from the PCR machine, cut and paste it into an Excel file, taking it from that Excel file, manipulating it in an Excel file. Okay, that's all gone now, right?
Right. Exactly, Dominic.
I mean, this is, your analysts must love. I know you don't have it on every project yet, right? It's hard to get it. There is some investment here, but or are you implementing it with every project? Maybe we haven't talked in a while, or at least a couple weeks.
So, we are in the process of getting this fully implemented here at KCAS. We're ready to go live with it, probably in the next couple of weeks or so. So, most of what we're doing right now is still going to be in parallel, where we're still doing that extra level of review, but
So a little heavy burden right now. You're doing almost a
it,
little bit, yeah, not twice the work because this doesn't take much work, but you're still doing it the regular way. You're pounding out batches in parallel here, convincing our QA department in the world that we can do this, right? That's what we're doing right now. Great. And you got a team of like 8 now or 9.
yes,
I could only imagine how they're looking at this going, oh, there's light at the end of the tunnel here. Our lives are going to get better, right? I remember within the poster, talk a little bit about that. What are some of the, you mentioned about 4 hours of time, but that translates, we had some numbers around that, right? What does that translate into? Like, if I had to run a standard batch of, let's just say digital drop PCR, maybe it's an RT version of things, and I've got 50 tissues. That might take in a current setting, the regret, because the time it takes to set it up is moot. It's the regression of the data.
Sure.
That could take half a day. You're saying for an analyst to get that, peer reviewed, or they have to review it, peer reviewed, and then into some sort of QC department, right, and or a second QC review, and then into QA. That's the normal process, right?
right.
With the, and so what does the what, again, I feel like Stephanie at Biodata had said she didn't want to call it AI, field was sensitive. What do you call it? Do you say red thread or machine learning? What do you say? You're like, Dom, I don't know either, right? But like,
Automated data analysis.
Yeah, okay, let's just call it that. But it is almost, yeah, we're using automated data analysis. God, it's funny how scientists get all really specific. I guess it's good and bad, right? But using automated data analysis, what's that? So say we had 4 hours on the back end of data tabulation in QC. What's it with your automated process?
It's probably less than 30 minutes.
Holy smokes. Think about that. Man, Lawrence Goodwin's looking at you going, when is this going to get implemented?
2 weeks.
And, but we're doing due diligence on
Sure.
the platform.
Yeah, you've been working on this a long time. I remember seeing over almost a year ago, we had a beta test and QA was working on it then. And you've had I think you implemented for a client, but no, sorry to kind of talk over you there. But yeah, you've been doing this for a long time. I feel like good for you. You got to be pretty excited. You said it reduces it by 30 minutes to 30
minutes.
Yeah.
And obviously it depends on the size of the project. The larger the project, obviously, the bigger time savings.
So what does that mean? So if you have to pound out 2,000 samples, that could take upwards of like 5, 7, 10 business days to do. This could take it down to a day. Is that what you mean?
A couple hours, maybe.
Oh, wow.
Just because, you can put all of the runs for a project into the automated analysis platform at once.
Oh, so if you got, say, 5 analysts running 2-3 batches a day, 30 minutes, it's done instead of all that data tabulation on the back end. That's what you're telling me.
Yeah.
Oh,
absolutely.
Wow. I guess we need megaphones and pom-poms to tell the world about this, don't we?
Well, I don't know. It kind of gives us, I think, an edge, right?
Well, yeah, we're the first. Others are going to adapt it. I think there's Stephanie, as they should, right? But it's always nice to be able to say you're the first.
Absolutely.
And and for those that aren't familiar with Biodata Solutions, and Stephanie Passes Farmer, she's a consultant, longtime farmer person, but she's in Lawrence, Kansas, and she's right down the road from us, and we really do enjoy our some of the. I'm always bragging about the Kansas City area. We're the 9th or 10th largest CRO city in the country, and part of that is obviously us here at KCAS Bio. But we got great colleagues like Stephanie, and so we work very intimately with her on that. And we, as I mentioned, that proximity allows us to really accelerate the process and troubleshooting and all the great things that come with it. So Carrie, you've got this wonderful thing. We're rolling up on we're over an hour on our podcast. Any closing things you want to say? I mean, I seem more excited than you do, but that's maybe just because it's Thursday and it's my birthday, so I'm pretty excited. But are you all? What else? What are your closing remarks around? Just in general, to share with us. We're working on a lot of cool biodistribution. You got some great biomarker stuff going on. Viral counts. That's another area, right? Is that viral, or you call it shedding, right? Viral shedding. Talk to us, carry us out on where do you see things? What gets you excited about the future of PCR, or in general about your service line?
Well, first off, happy birthday, Dominic.
Appreciate that. Thank you. I think I dropped that on John and even Jeremy. I was hesitant to even say anything because I'm 52 years young today.
Well, happy birthday. Another successful trip around the sun. But, the cell and gene therapy space continues to grow. Q2 pipeline for 2024, I think they're reporting, depending on which phase you're in, an 11 to 25% growth in new therapies that are coming online. So, I think that's really exciting. We still have some hurdles to overcome and with the PCR based assays, but KCAS Bio, we're really staying at the forefront of best practices as well as the best ways to manage the data. So I think that's really exciting from an industry-wide perspective as well as a KCAS Bio perspective.
Yeah, that's great. I guess it was easy to answer my question because you're like, look, I got this incredibly powerful tool over here that I'm ready to unleash on the world, right? And there is a huge demand on our bioanalytical side here, on the commercial side here. We certainly see the increase in gene therapies, in particular. siRNAs, right? They're becoming very hot things.
All RNA therapeutics are really growing.
Surprisingly, though,
they're not going to go away anytime soon. That's for sure.
But Carrie, you compete, and I say compete, but this is, I should start 1,000 reasons why I like working at KCAS Bio, right? But one of the things we talk about what really helps us with our tool chest. We talk about that when it comes to biologics. The tool chest for gene therapies at KCAS Bio is off the charts, in my opinion. And what I mean by that is, Carrie, a lot of these gene therapies, we can measure it by LCMS. We can measure it by a hybridization LCMS, which we're working on, a hybridization ELISA now, which suddenly these things are all the rage again. And I'm not, they've improved, but I mean, I don't know why we're not just doing it by PCR. I can't figure that out sometimes, right, Carrie? But you got all these, but that's a huge area. But really, one of the bigger things. Go ahead, John, and I'll just say the on-target, off-target is really
some of that's down to education of the client in terms of what technology might best work for the type of thing they're trying to solve as well. I mean, that becomes a discussion point, doesn't it?
Oh yeah, because everybody has their favorite way to measure their favorite DNA or RNA or molecule, right? I mean, there's still groups out there using branch DNA for better or for worse.
Yeah, for worse in our role. We're getting pinged. We're being told we got to get you onto the hot seat, right, Carrie? So, Carrie, thank you so much. Enjoyed that discussion there. Could feel for me the for me more some of the passion I have around just even cell-based gene therapies and gene therapies. I'm starting to when you mentioned all those things and phases, I thought, wow. And we're work. I would say a good chunk of our business now is dedicated to that. And I'm working with our VP of Sales, Alex, and we're going to share some numbers. And it's surprising to see how immuno-oncology, autoimmune and immunology are dominating. And the autoimmune and immunology is where these the RNA-based drugs are really having an impact. And we call them rare diseases too, but we bucket them there. So anyhow, Carrie, you're onto the hot seat. We're not going to ask you about your favorite podcast because you should say the one you're on. And so
Oh, the last
let's
one.
go. What was that, John?
Oh, the last one, because
Yeah.
yeah.
Let's go with let's start with what's your favorite dish to make? Maybe did you? I feel like you can tell us.
Oh boy. I guess I'm kind of known for bacon kolaches. Um,
Well, that came out of left
my,
field there, but I suppose your last name explains that. Tell us
uh,
about the kolache. What's your kolache's a big thing. What's your favorite one to make?
oh gosh, probably, yeah, probably an apricot kolache.
There it is. I would have guessed maybe a breakfast one, but you're going with the sweet treats and the apricot
Oh yeah.
flavors. Okay.
Yeah. Well, okay, now,
See, I got you
eh,
thinking about it. You're like, it's pepperoni pizza. No, it's supreme pizza.
no,
No.
what you're thinking of, I would not call a
Oh,
kolache.
I
So,
see. What is that called?
Ha, you
oh,
Philistine. Ha.
uh,
It's just, you're right. But every time I go to the kolache bakery, I get
uh-huh.
one of those breakfast treats. You're right. It's not a kolache. It's a breakfast sandwich, I guess. So my bad.
Well, it's like a dumpling
I don't know
almost.
what it is, but it's like instead of the apricot, they put a bunch of tasty treats in the middle of it, and I
Oh yeah.
love it. Yeah, no, good. That's awesome. Definitely one of probably our most exotic. Not, I don't know if exotic's the right answer, but probably the most from left field. Let's call it that. Most people talk about meats and dishes and stuff, and you're certainly the first one to say what I would call a treat of some sort. I don't know if it's necessary. It's a breakfast item.
Careful.
Let's
Uh,
move on to your favorite drink before John's UK side comes out and smacks me in the nose. Yeah. What's your
oh,
favorite beverage?
well, I mean, I guess it kind of depends on the situation, but summertime, I kind of like a good gin and tonic.
Ooh,
Um,
now you're speaking my language. What's your favorite? What's your favorite gin?
right now I've been drinking a lot of Hendrix.
Okay,
Oh, you
solid,
can't go wrong with Hendrix.
solid, solid.
Yeah.
So,
You got a tonic water do you like, or what else do you spritz it up with, or anything?
well, with Hendrix, you kind of got to go with the cucumber, right?
Mm.
Yep. Yep.
And tonic water, you can buy the generic brand. You don't have, because there's all sorts of fancy tonic waters now. You don't have one you like.
No, I haven't gotten into the fancy tonic
Yeah,
waters.
take a
Maybe I'll
look.
have to.
Yeah, there's a couple out there.
Yeah.
The name of it escapes me, but if you go to like a Price Chopper and look in like the section where there's mixers, in the
Mhm.
alcohol aisle, you'll see your normal gin and tonics. But look up, there's a 4-pack. There's like a brown label on them, and they got a couple different brands. They're in cans, and those
Huh.
are a little bit tastier, little more expensive. And again, I could look it up here, but I'm too lazy to, because I want to.
And if you want a gin tip, I'm always going to jump in with this. Look out for Chase Extra Dry Gin. Chase are a small producer in Herefordshire, and they were bought out by Diageo. And I know they've come over to the US, but they're more difficult to find. But their dry is really really nice.
Okay. I
Yeah.
was gonna say, I was like, where am I gonna find that in Kansas
No,
City?
you might find it. You'll be surprised. I've certainly been able to buy it over here, but I bought it online.
But okay.
Yeah, so I'm sort of I'm travel when I'm going back to the UK next week, and one of the nice things is there's lots of little producers making their own gin, and one of the places I'm stopping at is a town called Sedbergh in the north of England, and there's just a place I was like a restaurant and hotel and stuff. They're producing their own gin, so that's one of my targets when I'm over, like I say, in the next couple of weeks, and see what else I can pick up as well while I'm there.
Good times, John. Good
Yes,
times.
Nice.
exactly. Gin is always a good thing to track down.
Yeah, I like Uncle Val's. There's a good one for you if you haven't tried that one, Carrie.
Well, for years I didn't think I liked gin, but
Yeah. Hmm.
I guess maybe I've grown up.
It's difficult to go
Yeah,
wrong
I
with
want
it.
to share one. Lately I've been doing tequila mezcal with a mixer, and that's been fun. I don't know. It's a tequila reader or something, a mescalita, mescatila. I don't know. I'm stupid
Hmm.
this morning, but it's been tasty. My wife has kind of liked them, and the weather around here has been a little bit hot, but it's been a wonderful summer to sit outside and have a cocktail. And a gin and tonic is always one of my favorites. And Carrie, you are right. I definitely did not start liking them until I was a little bit older in life. Although I always like the clear liquor because it makes me feel a little better. So unless you buy really expensive dark liquor, and then you don't have to worry about it. So it's been a pleasure, Carrie. Usually we ask a little bit about weekends. You got any good plans?
Yeah, we got time.
Just kind of your typical summer weekend. We, actually have a wedding to go to, and so it's sweet corn season, so it's time to pick sweet corn here.
What is that? It's time to pick sweet corn? What does that mean? You go to a family farm, or do you own a farm, or do you have it in your backyard?
Oh, I'm a farm kid, so I've got access, and I will go out in the field, put on my old muddy shoes, and actually pick it.
And you put the kids to work?
Oh, of course.
Yeah, you got to pay them a little bit, right? No, I mean, I understand you might not take an income, but you got to give the kids a little something, right?
I feed them.
They get fed, exactly. That's enough.
You're the best. I get my kid up on the ladder, pulling stuff off or doing stuff for me, and he's turning around like, "Yep, I'll buy that on Xbox." I guess I got to be a better parent here. Yeah. Ryan's off to college next Friday, so that's stressing my wife. Actually, it's 2 Fridays from now. That's stressing us a little bit. And then I head to Lyon on Monday, and that's got me a little anxious. It'll be my second time over there, and exciting stuff there. But John, close us out, or Carrie, or however.
Yeah, I'm gonna tell you where I'm. This weekend is a very quick trip to Boston for me. It's the time to see my eldest son and take in a couple of chameleon shows. One of which is in New Haven, but yeah, New Haven tomorrow night, Boston Saturday, then back here Sunday. Ready to start packing to fly to the UK on Thursday. So yeah, I've got a jam pack.
You're acting like a 30-year-old. That's awesome stuff.
Yeah.
In New Haven, you got to grab a slice of pizza. I think New Haven, Connecticut has the best pizza in America. With that, thank you, Carrie.
Absolutely. Yes.
Thank you.
Yeah, thanks very much, and we'll close up.